Hi friends, today we are going to talk about digital transformation. Okay, let's get started. Well, some of you might be knowing me already, but for you don't know me, this is the video I'm recording from London, and I'm an IIT Kanpur alumnus. So let's get started. Okay, um, today I'm going to talk about some of my experiences in leading digital transformations in my career, and we'll focus more on how digital transformations look like, why they are necessary and why they're happening in the world right now, and what's the final outcome you should aim for when you're doing any such digital transformation for your client. Okay, well, so I've driven, let's get started from the first point here. So I've driven enterprise level IT solutions wherein the client asked to deliver some sort of software technology, engineering or IT solution at an enterprise level. Some of those solutions started small, but then as in time passed by, they went into an organizational level. And I've driven a lot many of these transformations or projects or solutions wherein a complete, there was a requirement once to develop a software for the organization to um, provide an algorithm essentially to have a match on the supply and demand side of the things um, for the resources, for the human resources on different skills being suited to different roles. And I started this project as a very kind of a side gig, working on something else, and then I started this project as a side gig, as in when the client requirement came along, and then over a period of time, this solution became massive. The there were a lot of steps involved in that. I'll just talk about in brief a few of them. So any of these sort of projects where you need to develop some algorithm to achieve some goal, then it starts small with gathering the requirements. Okay, this is what the client needs. So some kind of framework, guideline, or requirements jotted down from the client on what's the actual outcome they would like to have from that solution. Then it goes on to gathering data. So you need to gather data around those elements. So for example, if I'm trying to match different skill sets and people having different skill sets, of course, with the roles that the organization has in different profiles, different departments, and so on, then I would first of all gather the list of people with different skill sets, will try to complete that data set. Even if it's not there, then I would like to have some surveys being sent to people, or some requirement being sent to the people, to the resources within the organization to fill up their skills in some sort of form. And once we have that, then I would do some analysis of the different roles that are currently open. So these are the two basic elements for this kind of solution where you need data, because when you start your algorithm, you obviously need to have, besides the logic or whatever you'll think about, you need to have um, some sort of data available with you over which you will try and test your model, and then actually try to see how that model applies to the whole bunch of data. So you might need to create some dummy data as well in such cases. So the approach normally is get the requirements from the client, deliver create some sample data, even if you don't have the actual data, then develop a prototype and deliver that to the client, get their feedback. Once you have a good feedback with you, then you can actually go on and build a solution. If you need a team with different skills to build that solution, because it's an X and Y technology with some more elements around the whole engineering or software development lifecycle, then you need to gather your stuff, gather your resources, get the team rolling up, and then start building up that solution. Okay, so I've driven a lot of enterprise level IT and management solutions, even risk solutions for different banks and so on. I worked mainly in analytics, consulting, strategy, all these areas, and that's the reason I've started this channel. Um, I've delivered also a couple of big data projects. Big data is huge data. I mean, there's this is a full-blown field of study, which you can do, which you can read in your spare time. But big data is when you do analysis, or even when you do data engineering and integration of a lot of data coming in from a lot of sources. The scale of data is massive. For example, you get sensors data, or you get some data around the pictures being taken by a satellite. For example, you might have data around the chemicals or pharma data. So, for example, when this COVID vaccine was developed, obviously there was huge data that would have been gathered at the first place before actually delivering the solution. Or it's the same thing applies basically for any new vaccine that comes to the market. And when you do, integrate all those sort of data and together in a form which is consumable, then that whole process of crunching that data into integrating that data and then crunching that data into chunks that you can understand. So have a full distributed architecture and do the integration of that, and then start doing analytics on top of that data lake or data. Then it's all termed as big data. Okay. Then I've also worked on a couple of machine learning and AI models, um, which require um, development of or doing higher end analytics. It starts with higher end analytics and then moves on to do to develop some machine learning models where you have some training data set over which you build up a machine learning model with a desired outcome. So you want to say whether this particular, for example, this particular um, uh, customer would be profitable to you or not, to your business or not, and if yes, then how much profit that customer would bring along in how many days. So those kind of problems are handled when you do analysis on your data sets, and then you try to develop machine learning algorithm that can actually predict or give you a probability of the outcome that you want. Okay, so that's all machine learning and AI that I've done. A few development of those ML engineering models, and AI is an umbrella under which you have machine learning. So AI is, or artificial intelligence is, quite a big field, applies to a lot of things, and machine learning is a major part of artificial intelligence. Okay, I've also delivered 360-degree customer experience, wherein I worked with a few product marketing teams for different clients and understood the whole customer journey, mapped the customer journey, got the feedback from customers in the form of different surveys and all which the client did, and then my role was to integrate all those data pieces, consider the whole journey flow right from the thought that a customer has about buying a product or service, and then what is the journey that they undertake by through their different devices. They might search for those product services. They might go to the website, client website, or many other websites maybe. And then what journey they would take there, in the sense that they might search for the products for a few days. They might then actually go on adding those products in there in the cart, for example, and then they might look for offers, stuff like that. and then ultimately complete the whole marketing funnel, conduct sales, and then once the delivery of that product or service is done, then the customers will probably give some sort of, or might give some sort of feedback. And so this whole completes the 360-degree customer experience life cycle. And at the end of the day, the goal is to find out whether the customer would probably become a repeated customer or not. If not, or how much the customer actually got interested or got value from that particular product or service that they bought. Even if they did not buy, then what were the reasons that they did not buy? So a whole journey mapped around the customer experience is called 360-degree customer experience, and I've done a few of those for the clients. um, as I said, I think I already covered the marketing funnel, and the marketing funnel is essentially the whole journey that you undertake as a marketing manager, to or not, you don't undertake, basically you define a journey that the customer would actually undertake, right from getting the leads to sorting or filtering or prioritizing those leads into qualified leads, to signups, and to from signups to actual conversions, and finally the feedback that the customer gives. So this whole marketing funnel would look very broad, wide in the beginning, because you might get 100 leads through your marketing effort, but then out of that only maybe 60 leads are leads where 60 leads or people, essentially your customers, users, are people who are actually interested in your product, and the remaining people just saw your product, and then they probably not interested at that point of time. They might come back still, but they might not have been interested at that point of time. So they might not like to leave their email, but let's say only 60 customers left their email, um, for the client to get back on those things, or some sort of whatever the journey you have mapped in your solution for the customer to take. There might be some sign up involved and so on. So out of those, let's call them qualified leads, and then out of those qualified leads, let's say only 40 people actually do the sign up on your website, and then out of those 40 people, 30 people basically choose some product and add them to their cart. Let's say you run an e-commerce site, and so the customers, only 30 customers might actually create their cart, and then only 10 customers might actually go to the checkout page. And then finally, when it comes to the billing part, maybe only 7 will pay. So your 100 leads actually converted into 7 conversions, and then how much time it took for, on an average, for a customer to get converted from the lead, and might be your total tenure of your marketing funnel. You would like to have the life cycle, this whole tenure or life cycle, to be as short as possible. So you want your leads to be converted obviously as soon as possible, maybe the same day or whatever. But then this whole analysis or creation of this marketing funnel actually helps the product marketing teams to decide their, or to devise their marketing strategies, and and optimize them. So your goal as an analyst, or as a person who is developing some digital transformation solution, with respect to the marketing funnels, your goal is essentially to paint a good picture based on the data. Based on the data, of course, strictly based on the data. Even if it's not good, then obviously it's not good. But so whatever it is, you need to paint a clear, concise picture of how the marketing funnel looks like, so that the marketing teams can actually look at that and see that, okay, maybe from 100 to 60 is a 40% drop, but from 60 to 40 might be 33% drop, right? From 40 to 30 might be 25% drop, right? So they are more bothered about where the actual, or the more drop is happening at which stage, and then they would try to put up some offer, put up some sort of optimize the flow there at that particular point in the funnel, so as to decrease the dropout rate and increase the conversion rate, in the sense that the customer moves from one stage to the next stage as soon as possible and more as possible. Okay. Now, I also driven a lot of data-driven decision making in the form of actually um, making decision or brainstorming the decisions to be made on the solutions or on the available data, which is again very important when you do analysis of, for example, the risk data in your bank, and then take decisions that, okay, this customer should not be issued a loan at all because it's a high risk customer, or maybe if the loan is to be issued, then it has to be within this limit, and so on. Okay. Enterprise data strategy is similar to enterprise level IT, but IT is more at the implementation level, while enterprise data strategy is more at a decision making or a strategic level. So based on the available data, views, and other elements which are required to take a decision, I have been participating in those enterprise level data strategies, and I'm talking about in general strategies, but then data strategies is where you would actually devise strategies around how your organization's data is to be used in a uniform manner and can be utilized for the benefit of many purposes and could serve many purposes. So you need to decide, okay, how your data flow would look like. So you might have 100 sources of different pieces of data coming along from different departments, and you would like to connect those um, data elements, relate those data elements with each other, and make some meaningful meaning out of that. So this is all about data strategy. We can talk in length about that, but right now I'm just talking about in that in brief. Okay, cloud transformations. So as you know, cloud is a big buzzword these days, wherein the clients or the organizations are moving to cloud very quickly. They don't want to live in the primitive world with on-premise solutions, so they want to have things around their whole applications getting moved to the cloud for its obvious benefits. I've created another video on cloud, so just have a view of that video, and you will understand the detail level elements that go in the cloud. But yeah, cloud transformations involve cloud migration, moving from your legacy solution to the cloud, and then within the cloud also, if you want to have new elements in your cloud, then you need to consider that during the migration part. And then after that, if you want to switch between different cloud providers, then what is the strategy you would have? And then ultimately, once you have the solution in the cloud, then how do you support that solution is also quite important. Okay. So I've been participating or leading, in fact, most of these solutions for the client. So that's all about digital transformation. I'm just giving you an idea so that you know what are the different things you happen and in organizations, big organizations and even small ones, and then what level of contribution that you can make and in which area. So if you are, for example, very much oriented towards marketing, then you might go towards customer experience and marketing areas, or if you're interested in data analytics, then you would probably try to deliver on that part. But if you are more strategic, you are more a person who analyze the data, and rather than creating a solution to analyze the data, you actually make decisions, good decisions on that data, then you might go in the enterprise data strategy area. Similarly, if you are a person who is quite interested in the cloud transformations and cloud strategies, then you might take up the cloud area, right? So that way, this is something which is like a bird's eye view of what different elements go in the transformations that are happening right now. Ultimately, the goal of all these digital transformations is to automate and digitalize the solutions that the client has for its obvious benefits, which are developing a robust, reliable, scalable, quick, and sort of automated solution um, to deliver value to their clients, to their customers, right? Okay. Now, some of the challenges that I faced in these transformations have been resistance to change. That's the first and most important thing you would face in every element of transformation that you work, because transformation in itself means a change, right? And people and human beings by natural instincts resist a change. You would see that the resistance to change even in your home for the most basic things. For example, if you bring something for your parents, and the parents will say, maybe I don't want this, my old watch is okay, but you are giving me a digital watch, or sort of those things, right? So resistance to change is a common thing, and in enterprise level transformations that you undertake, there will be many stakeholders there from the client side, and you need obviously a sponsorship from them to actually deliver the solution. So you need to undergo maybe a tough negotiation and those sort of things, lot of meetings obviously, and then try to convince the client on the transformation that you're going to bring, or the change that you're going to bring, how it would affect their employees, how it would affect their customers, and so on, how it would affect their culture as well. And so those resistance to change is the most important challenge that comes along in those when you undertake such kind of transformation. Culture, again, if you, for example, push for some solution while the culture of that organization doesn't support that. So within an organization, for example, if you consider any old organization, there would be some culture set up in that organization where people think along some line, and then it's difficult to break that line all of a sudden. While if you see some modern organizations, there is obviously an element of urgency in some cases, and then the culture behaves like that. So if you bring along a change and then you say, okay, this solution, this whole transformation will take 6 months, if you take that sort of thing in a modern age company, they might say, okay, 6 months is too big a time. Can you do it in 3 months? While if you take it to a primitive to an old organization, not primitive, but to an organization which has been in business for last say 50 years, and then you say, okay, it might take 6 months, they'll say, oh wow, just 6 months, okay, go ahead, right? Because they won't believe it, that it can happen in 6 months. Then if you don't deliver, then they would say, okay, no, I know, I from my experience, we already knew that it's going to take 2 years, while you said 6 months, okay, right? So those kind of things set up in the culture. Third is bias. So obviously, when you bring along a change, some people, some stakeholders, or the people who are getting affected by that change might already have a bias around those things. So, for example, even choosing between different vendors, some people might have had experience about working with different solutions by different vendors, and you might suggest some vendor who some of the stakeholders might not be favorable about. So because they already had in mind, okay, this is the thing that's so those kind of things where there's a set bias, either in the form of the solutions that you are delivering or the way you are delivering, even on the things like if you say, okay, I have a team size of 5 people, out of which 3 are developers, one is project manager, and so on, then they might say, okay, we need 2 project managers, or we need one business analyst within your team. Where is that person? Because otherwise, how will you understand our requirements? So, and you might say, no, it's not required because the requirements are already jotted down and they are very clear. So we just need an engineering team to implement. But they might have a bias already. Some people might already have a bias that, okay, there has to be someone like a business analyst to deliver that, right? So you have to overcome that bias. cost versus value. So any new solution transformation or whatever you propose to your client, there has to be a cost benefit analysis that should go along, because at the end of the day, what your customer or client wants is to have value within that particular cost, right? So even if you are proposing high value, but the cost is more for that solution, then they might not prefer that. Instead, they would say, okay, go for a tactical solution because that's going to cost me less, right? So those kind of things happen always, all the time. Data integration, actual implementation, change management, these are another a few other challenges that you would face in such situations. So you might say, okay, I want to deliver this solution to the best possible manner, I want these three sets of data, while the organization can say, okay, no, I don't have these sets of data available with me. And even if we go ahead and try to procure those data sets, it will be very challenging, very difficult, it might take a long time. And why do you really need that? And then you can argue on that those things forever, right? So you have to apply some sort of intelligence and logical thinking around that. Okay, what is a minimum viable data, minimum set of data that you might need to deliver a reasonable solution, and then you can take that middle line, propose that line to the client and get their agreement and get working on the solution. Okay. Security is again very important fact, because when you deliver a solution, especially these days when so many cyber attacks happen, you would like to have the client would like to have a solution which is fully secured, which might come with a cost and time thing, but then you might not have considered that aspect very well when you actually created your code, right? So you can then include those elements, and then some elements might not be implemented straight away in the first release. So you might propose those kind of things, and the client might or might not agree, depending on the sensitivity of the solution and so on. So you need to track, you need to traverse a difficult path in such cases as well. Okay. Now we'll talk about some responsibilities of a chief technology officer. um, they need to have a vision, right? That's the first thing. The CTO should also know the enterprise architecture, some idea around the enterprise architecture, how the overall solutions would be created and behave in terms of when you deliver that to your client, or even for your own company, any solutions that you are trying to develop. That CTO should have full visibility around the architecture of those, because once the architecture is set and the solution gets delivered, it will have a long lasting impact for say 10 years, next 10 years. And if the architecture was not good, then obviously it will come at a huge cost, right? And there might be other problems as well. So the CTO should be well aware of the enterprise architecture. It starts with the vision, know the architecture, know the strategy, high level strategy of the solutions, technology, especially focused on technology and digital transformations, that how the strategy should look like overall over a period of time, how it would affect the organization as a whole, and whether the strategy is in line with the futuristic goals as well. So because if the CTO, for example, is not that much strategic, and he might be a bit tactical in nature rather than being strategic, then the CTO might actually suggest solutions which are tactical in nature, and that might create technical debt over a period of time, because they might not have been able to think about the long lasting, the long term impact of those. For example, if the CTO says, okay, I want to have a solution or an application being to be developed in this particular technology, while that technology is say already obsolete in the market, or it's not future oriented, so it's not cloud based, for example. And if there was an alternative to go for a native cloud solution, keeping the long term things in the keeping the long term goals in mind, then that might go for the whole development of that application might be useful only for that maybe only for that point of time, but then as and when the time goes, maybe next year is not useful at all, and then you need to have a redevelopment of that application, resulting into huge cost and time losses, right? um, then the CTO should be aware of the technology stacks, overall technology stacks that are going to be used for different applications, the infrastructure that comes along with those technology stacks. So, for example, if you are a company, say sort of Walmart, and you have a full retail solution as your business offering, and if you are a CTO or you belong to the CTO office, and if you are not aware of the various technology stacks, for example, there might be a need to say collect data, integrate that data, deliver some sort of analytic solution, or manage and then manage your inventory, solution to manage your inventory, a solution to optimize your transportation and logistics delivery part, and then the management of the store and so on. So there are many areas which need, obviously, everything comes with infrastructure, and I'm talking about more on the technology infrastructure that you need rather than physical for your business. So technology, in terms of technology, you might need some sort of, say, cloud infrastructure. You might also need some servers, security elements, and there might be databases, obviously, that you need, right? So all technology stacks, and a stack is essentially a set of combination of technologies that work together to deliver a solution. So you might need some front end. Let's say you have an e-commerce website, or even for your store delivery, you have a website where the people order and then you deliver the products to their homes. That whole website might have a front end which is to be developed in some technology, say React or whatever, and then you will have some backend technology in the background. So you might have some database, for example, MongoDB or whatever, right? So that way you need a number of technologies to work together, and that's all technology stacks, and the infrastructure that you need to, or the environments that you need to deliver that whole software development solution or DevOps solution. Then you need to be aware, as a CTO, you need to be aware of all that, right? Innovation should be there as a first thing in the mind. So CTO should always concentrate on innovation, and innovating things. So they should be able to look ahead in the future and try to think out of the box, and the best possible solutions come out with new and never seen before. They should also have some strength to traverse uncharted territories if required, and bring out some sort of disrupting a solution which completely changes the market, and puts your organization to a place where you have an edge over the competitors, right? So innovation is a very organic, best way of delivering or moving ahead of your competition, and delivering more value to your customers with less, I would say, less overheads. So if you have a product which is, I mean, in terms of, it's just in general, but even in terms of technology, if you develop some mechanism through which the customers are like, they take maybe just 2 minutes for end to end to order their cart, and it is very easy to use application, mobile app, and so on. So those are, they might not be considered as innovation as of now, but then it would have been an innovation when it actually first came along, and some companies moved ahead of that. For example, Apple is very good example of a company that continuously innovates, and brings around those smartphones, iPhones, and then smart watches in the market before anyone else does, right? And they are of great value as well. So those are the things you should consider as a CTO. Products and services, obviously, the whole goal of delivering your technology solutions is to ultimately deliver some product or business service that your business caters to, right? So product or service, or whatever your business offering is, that should be the first thing in the mind, and then the technology solution should be built around that to produce that, rather than vice versa. So you should need to have the front part, which is what actual product or service you're going to deliver to your customer, and then how you deliver that then has technology elements which you can then think around as a CTO. But your focus should be, okay, this is the value, this is the product that I'm going to finally deliver. For example, say an e-commerce retail website or some sort of mobile app which achieves some purpose. That should be your goal. And then how you achieve that purpose can be in different technology, using different technology stacks, infrastructure, cloud, and so on, right? Okay, so then comes along security. So as a CTO, you should definitely, for every solution that you deliver, should have security as the most, uh, I would say not one of the most critical elements, but the most critical element for any solution that you're going to deliver. If the solution might be very nice, very good, easy to use, easily logged in, the person can easily log in and do the order, but then if it has vulnerabilities that can be exploited, and there are chances of fraud, for example, then you should definitely plug those holes first. You should think about those first before even developing that or delivering that solution. Okay. Build a strong team, of course. So you need to divide your teams, maybe between between teams who are focused on design and architecture. Then there might be teams focused on the software engineering part. There might be developers. There might be teams who are actually managing the whole process as a DevOps team, the deployment process, and so on. And then you will have a set of software testing specialists, QA specialists, who would make sure that the solution that's being delivered is bug free and is of high quality. And then there might be other people who would be more required from support point of view, right? So you need to have a design and organizational structure for your technology teams, and the goal is to have the strongest possible teams on the ground to deliver the best solutions that are possible. Okay. Fine. Now, there's a difference between the chief technology officer and the chief information officer. Um, so CTO normally focuses on products, while chief information officer focuses on processes. So what are the different processes being undertaken in the organization, whether they're optimized or not? For example, the change management process, right? So as a CTO, you would still think about the whole change management solution and the technology behind that, but the CIO would focus on how that change process would look like. Okay, right from the user who is actually raising that change to getting it approved through the board, then what is the process of delivering that change, within what timeline, and then who all will be intimated, and who all what documentation might be required for that process, and so on. So CIO focuses more on process, while CTO focuses more on products and services. Technology versus IT and operations. Again, as I said, CTO focuses more on how the technology, underlying technology would look like for a solution to be delivered, while the CIO would focus on how that, once the solution is delivered, then how it would be supported in an ongoing manner. So what are the teams required to manage it from an operations point of view? So you might need some L1 support, L2 support, who are the people facing the customer to handle their queries, and then if they're not able to handle the query, then they would pass it on to maybe L3 support, who would be more technical guys, who would then find a solution to that problem and inform the customer. So the CIO focuses more on the day-to-day IT and operations, while CTO focuses more on technology. Okay, CTO focuses on innovation, while CIO focuses on efficiency, right? So it's not that the CTO will not focus on efficiency or CIO will not focus on innovation, but the more um, more strategic or new solution that you want to deliver is sort of responsibility of the CTO. While once a solution is in place or it's going to be in place, then how you would optimize that whole thing is CIO's role. So if let's say there is a life cycle of um, a piece of or say some process takes 4 days, then the CIO would think about how I can reduce that process to be completed in 2 days, while the CTO would focus on how that process is to be optimally driven in terms of the best possible technology, ease of use of the solution, the features that that whole solution will have, and so on. Yeah, while the CIO will focus on how best to utilize those features, who are the teams who are going to utilize those features, deliver the solution, or have the life cycle of that whole process in shortened time, right? So that's a typical difference. CTO focuses a lot on the customers. So what is your end product to service would like look like to the customers and so on, while CIO focuses on more on the employees. So how once you have delivered or you're going to deliver that solution, and it would behave like this to the customer, then how your employees and the teams would actually shape up to produce and support that solution. These are not a hard line difference. So CTO might also focus on the right hand side of these things, and CIO might focus on the left hand side as well. But more or less on a broader point of view, that's a difference between the responsibilities of CIO, CTO, and CIO. Okay, choosing the right solutions. Um, sorry, choosing the right solutions provider or technology vendor. This is quite important when you deliver any digital transformation, because it again, as I said, any solution that you deliver will have so many strings attached to it. It will have a cost attached to it, and once the usage starts for that particular solution, then obviously people will be attached to it, and it's difficult to then change at a later stage any of the core elements of that solution. So you need to choose the right solution provider for different cases, in terms of the actual value that you're going to deliver. So you should be futuristic, fit for purpose. So there might be, for example, a cloud solution which is fit for say machine learning work, but the solution might not be that great when it comes to data engineering work, right? And there might be some other cloud provider who is providing more a better data engineering solution, platform, or where you can do data engineering. So in that case, if your solution is more data engineering oriented, then you might choose a cloud provider who is providing that. Flexibility, how the cloud provider might the sort of solution from there, or the software from the cloud provider, or not cloud provider, but any solution provider, is flexible or not, whether it can accommodate changes at a later stage, whether it can be customized or not. For example, you might want to have an say an e-commerce a set e-commerce solution from some company, but then you want to customize it with your say organization's logo design and how it would appeal to your customers. You might want to have a different theme, for example. So if the solution, if the vendor is providing that sort of thing or not, right? Similarly, then the vendor's experience is quite important. Cost is the most important element here. I should have put in the cost in the first point, because if the solution, if the software that the vendor is providing, on top of which you will build your solution, or use a solution or use a software directly, then the cost is extremely important, in that sense, that what will be the capex cost to procure that solution, the set software, and then what will be the operating cost, so that the running cost of using that software or solution. The reputation of the vendor and agility, so how quickly they can respond or change, or whether they are versatile or not. So those kind of things you need to understand before choosing the right solutions provider or technology vendor. Okay, and those technology vendors can be, for example, the cloud providers, the database providers, or you want to buy a complete say a retail interface for a sort of internal solution to manage. For example, if you run a restaurant, then you would have a restaurant software being procured by some technology vendor. You might want to develop your own, but then there might be some standard set of restaurant software which manages the orders, customer, generates bills, and takes care of even say marketing efforts, generating offers, and managing the employees as well. So if that solution is already standardized and provided by some vendors, then you can go for buy. So there's always a thing between buy versus build. You might want to have some solutions developed from scratch, while you might want to have, and there you would use those technology vendors, the software or solutions or technology to create your own application, while in some cases you might want to just directly use the application or software or technology solution provided by the vendor. Okay, so there might be different use cases for different scenarios. um, Digital marketing, so we'll just talk about a few bits around digital marketing. Understand your customer. Marketing funnel, I already talked about. Different channels that are being used, influencers and affiliates use tools, measure feedback to product teams. This slide is maybe not that much relevant to the talk that we are delivering today in this video, but probably I had put in with some purpose which I forgot right now. Okay, so we'll talk about this more in any of our later on. We'll create some videos around digital marketing where we'll talk about all that, but understand this point as well, that any digital transformation that you deliver will obviously have some element of digital marketing attached to it at some point, or it might not have not have, but there might be still some use cases where you deliver some solution, and it doesn't appeal to your customers or to the client. So there you need to think about all those things. Focus on trends and futures. So whenever you deliver a digital solution, you need to focus on the futuristic goals and future, not just goals, but not just your own goals, but how the future is shaping up in the world. For example, IBM and Microsoft's brain brought the computer revolution, Google brought the internet revolution, Apple smartphones, Amazon brought the e-commerce and probably cloud as well. In the form of AWS, Meta and Twitter brought the social media revolution, Netflix brought streaming revolution. So I'm sure once you read all this, you will be able to relate. You will relate how much these companies would have thought. Because if you just think about it, if you think about, for example, internet, when Google started way back in 1990s, 97, 98, something like that, internet was in a very nascent stage. And with that, with the search algorithm that they brought around, the whole picture or the whole shape of internet changed. And these days, you don't even in some cases when you do a search, you always say, okay, I'm Googling this. You don't say that, okay, I'm doing a search on the internet, right? Similarly, when you talk about smartphones, a lot of times you just talk about, okay, I want to buy an iPhone rather than I want to buy a smartphone, right? Similarly, when you order something from through an online portal, sometimes you don't even care to say that, okay, I ordered it from Amazon, because by default, you know that anything that you order in e-commerce there's a highly likely chance that it might be from Amazon, right? When you talk about social media, you are generally talking about two or three major platforms only, right? Facebook, Instagram, Facebook is now called Meta, and then Twitter, right? So these are the major social media platforms. There might be hundreds more, but then these are the major ones, and these are the ones not just in terms of okay how big they grew, but also the fact that they were the pioneers of this whole thing. So the whole point that I'm trying to drive here is that when even Amazon started, it was in 1990s, and nobody knew about e-commerce, right? And Alibaba started in China. So Amazon and Alibaba were the pioneers of this whole e-commerce revolution. Meta and Twitter brought the social media revolution. They were the pioneers. They were the people who, they were the companies who started this whole area completely. It's not that social media did not exist. Social media might have existed and on an offline manner, mostly in an offline manner before, but the whole online social media revolution came along when these platforms came in the market. Similarly, Netflix is very much new age revolution. They brought the streaming revolution, right? So Netflix is an old company. They worked on, or they provided CDs and all those sort of movies, media, DVDs, and so on before for a very very long time, and then they brought this streaming revolution. All of a sudden, the market went berserk with with that, right? So these are companies who brought the who have been the starters or the technology disruptors in the market, completely changed the shape of the market completely. I have not talked much about IBM and Microsoft right now, but even I think out of all these, the most that have actually impacted our lives are the IBMs and Microsofts, because they brought the first computer or the usable consumer sort of usable by consumer computer in the market, or the operating systems in the market, and all the mainframes which actually drove the technology behind literally every company in the world. That was IBM's, right? So how much they have impacted our lives, we all know it, and we might not appreciate that because it might look like a default, like a general normal. It's a new normal, but um, if you actually think about all this, and if you want to be a technology disruptor, and you want to do something for yourself, for your client, then you need to think around maybe 10 years, 20 years in future. When Amazon brought this AWS thing, it was way back in 2005 or 7, I think. Um, can you imagine this? While it has picked up only the last few years, but they thought about it way back in 2005, 6, 7. And the reason for that was they could visualize, they could see the vision, see the ultimate thing that, okay, there will be a time when everything will move over the internet network or over the cloud, to say cloud network. So those kind of things you need to understand and make your mind around, thinking around those lines if you want to be a disruptor, if you want to be a new age entrepreneur. And I'm not talking about much about blockchains and so on, but then the companies or the people who brought those changes are also in that league as well. Okay, currently that I'll just talk about a few top trends which are currently there in the market, and then we'll probably wrap up the discussion. Yeah. Okay, so top trends in the market right now in 2022 are cloud, artificial intelligence and machine learning, blockchain, DevOps engineering, metaverse, or I should say, yeah, metaverse. Let's call it as metaverse and VR together. Um, Internet of Things, 5G. So 5G is getting rolled out in many countries right now, and it will be a complete technology disruptor because it's going to change the way we use our internets and mobiles. Very quick, very fast. Um, it has its own benefits. We can talk about that in length later on. Edge computing, and then cybersecurity, right? We already talked about cloud, ML, and AI. We'll talk about in brief about blockchain. So blockchain is a technology where you maintain a distributed ledger, uh, and it's a mechanism for data storage and data retrieval in a secured manner. So it's an algorithm, it's a technology. So don't just say blockchain, okay, it means Bitcoin or any other cryptocurrency. Cryptocurrency or Bitcoins are one use of blockchain, but then blockchain is having huge applications, huge need in fintech, in health tech, literally everywhere, where you want to have an immutable um, set of data, um, or a validated or a verified set of data being maintained by many different parties, peer to peer, and making sure that nobody changes that without validation from a number of validators, or without just you just can't change anything, or just can't look like the book. You can't just fudge the books like that with blockchain. And that's the reason it has huge applications in things like fraud analytics, and where you had want to maintain or have set of data which is non-changeable. It is still changeable when it goes through the correct process. So there's a process, number of people, number of parties are involved in that process, and once they all validate and say, okay, this is the right thing, then it gets added to the blockchain ledger. And once it is added, you can't change it. So if you have moved along and then you make another change, then you can track back the history and clearly say that, okay, this is not a transaction which happened, it's wrong, it's fraud, because it's not there in the ledger at all. Okay, we can talk about, again, I will try to create another proper video on blockchain where we'll talk in detail about it. DevOps is not a technology, but DevOps is a methodology, instead, which focuses on how focuses on development and operations together. So it's a methodology which says, or which defines the efficient manner in which you can actually deliver a solution. For example, let's say a software solution, how you manage that solution right from development to delivery, right from analysis and design to development to delivery, and maybe include testing and other elements in the chain. And then how the IT operations team would probably manage that solution, and whatever feedback is there, then they go back to the development team, right? So all this sort of process is called DevOps. It's a big line of work these days, and it's a methodology which has a number of stages. So we'll talk about, again, DevOps engineering in one of our other videos, but just to understand that it affects the whole cycle of design development to testing to quality assurance to automated delivery to management of the customer feedback, and then deployment of the solution, management of the customer feedback, back to the redesign if required, or iterative design if required, and then again the whole cycle process flows, right? Okay, metaverse is essentially, we talk about a virtualization of the experience. um so metaverse is mostly related to, I mean, it's a big word, again, it's a big area, but the foundational elements of that are the virtual reality, augmented reality, and so on. So you might have, for example, you might have seen putting up a Google Glass or some sort of device in your eyes, and then you can play a game in the virtual world. Maybe you are just standing in a room and you just put up a glass over your eyes, and then it looks to you in the virtual world. You will see a number of images flowing. You might actually play a complete video game there, and so on. Metaverse has huge applications when it comes to actually doing the practical use cases. So, for example, you want to like on an e-commerce site, you want to buy some dress, and you would like to know how that dress would look like on you, right? So, and it's a virtual experience. So you are not there in the store, you are in your home, and you are ordering something, but before order, you want to see how that dress would look like when you wear it. So there might be a metaverse solution, which, or a use case there, where where you would see in the virtual world that how that dress would look on you. So you might upload a picture or maybe just in the video, show the it will superimpose that dress on your avatar or on your human element, and then in the virtual world you will be able to see how that dress would look like, and then whatever looks good, then you might want to order it, right? So those are the practical applications of metaverse. Again, it has many huge applications, use cases, which are not yet. I would say it's in a nascent stage. It might take a few years before the actual technology or the actual applications come out in the market. Internet of Things is where the things are, where the devices. I mean, again, it's a big word, but where you have um, elements connected to each other. So you might go for a run and be wearing your Fitbit, a smartwatch or whatever, and then that data comes along when you come to your home. That might be connected with Bluetooth. It will get connected to another device, and then you can analyze your data. It might also suggest you something. Similarly, let's say you are playing some video on your mobile, and then you want to cast it on your TV. So again, you would connect it with your TV through Bluetooth or whatever. And this is just one or two devices I'm talking about, but there can be like 10 different devices being connected with each other, and doing some different function. For example, you might have Google Home, Alexa, or whatever in your home, in your home, and then you would like to connect that with, say, your robotic cleaner, and you might want to connect it with the smart lights that you have in your home, the doorbell, and so on and so forth, right? So you will have 5, 6, 7 devices connected with each other. That's all technology behind that is called IoT. Okay. 5G is a mobile thing. Every 10 years, normally you have another G gets added. So you had 3G, then 4G, and now 5G. It works on the principle of delivering greater speeds for your internet, broadband, and telecommunication. While it has some obviously infrastructural bottlenecks. So you might need receivers at shorter distances and so on. But yeah, those bottlenecks are being worked out, and 5G is getting rolled out in different countries. It might still take some time to be at a full blown level, but yeah, that's a good technology to be. That might work as a disruptor for many of the companies or many of the industries as well. Okay, similar to how internet worked out as a game changer, right? So it will be also 5G might also be a game changer. Edge computing is where you bring along your infrastructure or virtualization to the place where the actual action is being taken on, which basically means that anything which is to be delivered fast. So the goal is ultimately to deliver or the response rate to be faster than what it is. For example, if you are browsing Alibaba website from say a remote country, or say from some island in Mauritius, right? So there you would, and if the Alibaba server is there in China, or let's say in US, maybe, we don't know, and that might take some time for the results to come back. So you order something, and then it might take 3 seconds to show you to show you the status of your order and so on. While edge computing focuses on bringing that whole response rate down by having a local infrastructure or a replication of the server or virtualization to the place where you are actually asking for the or making the request from. So you might have a small deployment in somewhere near Mauritius as an availability zone or something. Cloud providers are actually trying to do that to some extent, and then when you order, then it might take just 1 millisecond or 1 second for the response to be from Mauritius on that, right? So that way it's called edge computing. Again, it's a big field. We'll talk about that in detail in some other video. Cybersecurity, I've already talked about in brief, but cybersecurity is quite important. Any solution that you deliver should be validated or should be thought about that what are the different vulnerability points, what are the traceability metrics looks like for that, and then you need to undergo the full I would say, life cycle of the security testing before even deploying that solution, and that might involve, say, full life cycle of the penetration testing and other elements of it, right? Cybersecurity comes in different ways. So the hacker might install your network completely, or might try to steal data from your network, and so on and so forth. It has many elements again, but you would like to have good traceability metrics, and then put up the solutions on each of the different boundaries where it can be exploited, the solution can be exploited, and plug those goals with a proper fix or a good software that would ensure that those attacks and cannot or are minimized. Similarly, access mechanisms are fully secured. You might not want to have your data being or your or any file or component of your project being accessed by the unwanted parties. So all that contributes to the whole cybersecurity. So any solution that you build should have cybersecurity as the first important element, even if that solution then takes uh, a bit of time in implementation, or might come with some cost, but that cost is preventive cost. It's better to spend it before delivering the solution and make it secure, rather than getting exploited and then having huge losses in damages, and not just damage of your physical infrastructure, but also the damage that it comes around with the reputation that you have, or the brand value, or the data privacy laws, and so on. Okay, so I think we have covered a number of elements in, I mean, the whole topic of digital transformation is quite big, but then these are the things that I talked about are to be considered when you want to deliver a good solution or get a solution in place for your company. Um, so consider all that, consider the trends which are going there in the market, because any solution, any transformation that you bring along will have very far reaching effects, not just for you, but for your client and for everyone in the society, for the clients, customers as well. That's the reason, always think about that in detail, and then only go about implementing that solution. So have a long-term view rather than having a myopic view. Okay, what next? So we'll talk about what next in our next video. Till then, goodbye, and enjoy it. Let's meet up in our next video. Bye bye. Cheers. Bye.